Okay, let's make quick implementation of the spatial prisoner's dilemma problem. And the spatial prisoner's dilemma problem is just a prisoner's dilemma problem done over and over and over again many times. So we have this two-dimensional grid that goes on, and each square, each patch is going to be an agent, and each one of these guys plays with, let's say, his four neighbors. 1, 2, 3, 4, north, south, east, west. And he plays the prisoner's dilemma. So each step, everybody's going to play prisoner's dilemma with one of the neighbors, say randomly. And then, so everybody's got a fixed strategy, say, cooperate, and maybe this guy's doing defect, and this guy's doing defect, and cooperate. And so so there's going to be the play, but they're also going to change their strategies. And what we're going to be doing is you're going to change your strategy based on your neighbors, right? So you're going to look at a neighbor, and if he's doing better than you are with his strategy, then you're going to change to his strategy. So that's it. You just look around, pick one of your neighbors at random. Is he doing better than me? If so, I'm going to do what he's doing. And we're going to look to do that. Of course, we need to keep the history. So we're going to need to keep some sort of payment history. Payment history, right? So how much have we got paid each time step, 3, 5, 1, 0, 3, 3, and so forth. And so maybe we're going to look at, say the 10 last steps, because of course history could go on forever. So we look at maybe the 10 most recent or the 5 most recent. We'll vary that, right? So that's the idea. We'll look at how much he made in the last 10 steps, how much I made in the last 10 steps, compare those two numbers, and switch to the better strategy. So that's one way that people have studied this spatial prisoner's dilemma. There's of course a lot of variations. If you research the literature, you'll find a lot of them. So, but we're gonna do this one. What I want to do here is, so I'm gonna need to have some globals. I'm gonna hold the payoffs. So that's the prisoner's dilemma payoffs. And then I have to say that the patches own the payments. That's the history of the payments. Okay, I'm going to add my buttons here. We're going to need a setup and go buttons. Okay, to set up, I'm gonna ask my patches to set the color to green, and then I'm gonna ask one of the patches to set his patch color to red, and this should be P color. So what I'm doing here is I'm saying green is cooperate and red is defect. So that's my key there. And you see I have just one guy defecting, and we're basically going to see how defection spreads. Right. So to set up, I also need to clear all. Reset ticks. So I really should do this at the end. Okay. Clean that up. To go. Doesn't do anything for now. So set up. Okay, that's looking good. And now I also have to set up set the payoffs. This is going to be my payoff matrix. So it's going to be the list of lists. So again, I'm going to say cooperate is going to be index 0, and defect is index 1. Since the prisoner's dilemma is a symmetric game, I don't need to store for both players, so I'm only going to store for one player. So I'm saying so cooperate. So 0 0 is right here. That's cooperate. We're going to say that's a payment of 3. Cooperate defect. If I cooperate, he defects. I get a 0. If I defect and he cooperates, I'm going to get, say, 4. And if I defect and he defects, I'm going to get a payment of 1. So now to make this a little simpler, I'm going to put in a little helper function just to help me remember, to get the payoff. So report, I'm going to call this get payoff. I'll get payment, probably better. And then, my color, his color. So this is just going to be a helper function. I'm going to let my action, if else. So this is going to, if else value, if my color is, if cooperate is 0, which is green. So then that's 0, otherwise it's 1. So you see what I'm doing? I'm just changing the colors to indices. If else value if his color. And this should be a dash in there. My color, his color. If his color is again green, then index 0, index 1. And then I just report item. It's going to be, well, first is going to be item my action in the payoffs matrix, and then item of his action, and then his action, right? See if he takes 0. Okay. You can double check that, but I think that's right. So that's how I'm gonna get the payment. So to go, when we press the go button, I want everybody to go. So I'm gonna ask the patches to play, and then once they're done playing, I'm gonna ask their patches to update their strategies. Okay, so down here I'm gonna have my patches methods to play. I'm just going to pick one neighbor at random. The chosen one would be one of neighbors, and let's just use the neighbors to 4 neighbors. I could also just use all 8 neighbors by saying neighbors. So that's the chosen one, is the one I chose. I'm going to play against them, and I'm going to give myself a payoff. So let me get the payoff. It's going to be get payment of my color, which is P color, and his color, which is P color of the chosen one. Okay, so this is going to be my payment, and then I'm going to put that payment in my, I'm going to add it to the front of my payments list, which, by the way, I should initialize up here. So when I set it up here, I should also set payments to be the empty list. Okay, so, and I'm going to set payments to be, I'm going to put this guy here. So first put that into payments. So set payments to payments plus this at the beginning. I think that's it. Yeah. And so that's how I play. I check, and of course nothing update has been defined. To update, and let's go back over here now. This should all work. So I can ask patches to show payments. Payment. which one is it? No, it's payments. Go. Up, ask patches to show payments. Okay, so I had this wrong. I need to set this to observer. Then I can ask patches to set no, show payments, and they'll show empty lists as we might expect. Set it up again. Okay, so I can do that. Oops, I want to set it up and then hit go. Go a couple times and test this out. So you see they're getting 3 mostly, which is what we'd expect. Copyright, you get 3. So that looking good. Let's go now to update. What I'm going to do is, again, I'm going to have a chosen one, and it's just going to be one of my 4 neighbors. And now I need to calculate the gain. You know how much he has made and in that window history. So for that, I'm going to implement a little helper function to report gain. And then so what I need to do is get I have this this payments list. So I need to get the first, X. Let's make that a slider. So history length. Let's start out at 3, maximum 50. So history length is going to be the length of how many payments in. So I'm going to consider the 3 most recent payments. So to do that, I'm going to need to get the first 3 elements, and there's no built-in like first X. There's a first function that gives you the first element in a list, but not first X, which we need. So I'm going to implement that, a little helper function here. Returns the first X elements in L, or fewer if L is smaller. If L has only 1 element, then it's only going to return 1. So I'm going to repeat X times this, and I'm going to build a result. So set or let result be the empty list. If the length of L is 0, right, then I'm just gonna report the empty list because there's nothing there. Otherwise, I'm gonna repeat X times set the result to be F put. I'm gonna take the first one from L and add it to result. And I'm going to add it at the end. L put first of L into result. And then set L to be but first of L. So we remove the first one, we add it at the end. Remove the next one, we add it at the end, and so forth. If length of L is again 0, we don't want to crash. So then I have to report it. I also forgot that here. Bracket, report result. Then at the end, report result. Let's test that out. So first one in the list 1, 2, 3. Oops, first X, sorry. first x. Okay, that's 1. First 2, that's 2. First 3, that's good. And what about 4, 5? Yep, that works too. So you see, if we ask for a bigger number, it just gives us the first 3. Awesome. Okay, so my gain is just then is simple. Now it's just gonna be a first x of what was the name of the? It's called history dash length. First x history length of payments. And then my gain is gonna be the sum of those numbers. So the sum of those numbers, and I'm gonna report that back. Okay, so that's my gain. So if to update, I'm just gonna say if my gain, if the gain of the chosen one is bigger than my gain, then I'm gonna set myself to his color. Set my color to his color. Right? Otherwise, I do nothing. So that I think is the update. Set it up. Go, go, go. So this is what happens when you expect with this. I'm gonna add a infinite go button. Go to forever. If you press that, you see it grows. Set it up again. But you see if you increase the history up, oh, got nothing. So set it up. So maybe you might or might not expect this, but yeah, as you increase the history, so as we consider more and more in the past, the red, which are the defections, they have trouble invading. So you can think of this as like infections, right? The defections are infections, are infecting the population. But if people remember the past, then it's harder for the infection to spread, and cooperation rules the world. Whereas if people have very short-term memories, you get higher payoffs, and so everybody defect, which means the total payments are lower, right? So let's put a couple plots in here. So an interesting one is the total payments, for the last one. So this is going to be, I'm going to hit OK here so I can stop this because it's slowing my computer down. Edit. So the total payments, so it's going to be the plot of, I'm going to add up the first payments of patches. So for each patch, I'm going to get the first payment, which is the most recent one. I'm going to add it up. So this is going to give me the latest total revenue, if you will, for the system, I think. See that works. Yeah, doesn't. It's going to be a problem with that. Do add a tick. Forgot my tick here. So we don't want this to happen until after the tick, right? So what I'm going to do is I'm going to change this because we're going to need a little if else here. So if else value, if length payments is 0. No, wait, not in there. In here. The length of the payments is 0, so there's no payments. Then just plot 0. The sum of the number. I'm going to return the list with just the number 0. Otherwise, if the length of the payments is 0, then we're just going to plot the number 0 now. Otherwise, first of payments, oops, the first payment of that guy. Let's see if that's right. And so what we're trying to do is get at the first of the list. Even when there is nothing, we'll just use a 0. Plot 0 to be a number, but got the list. Oh, whoops. Yeah. But then I need to add that. I do need the sum of all of those. So the sum, right? So this is going to return the list of all those zeros. Add them up, should be 0. So our total payments are those. You see, it shoots up. It's kind of level because we don't have that many reds, but you see as the number of reds increases, the total number of payments or revenue goes down. So things are not looking good for our guys. We could also, within the same thing, although if you probably the skills won't match, so we can create another plot, which is the count, right? So population. So count patches with P color is red, and that should probably be in red. Red. Okay. And this one here. Plot count patches with P color equals green. And this one should be green. Okay. And go. So there you go. Green and red are down there. And we have our total payments are going down as we get more and more defection. And then we can reduce the history length, and you see the red take over. We increase the history length, and they flip back the other way. So you can play around with this. There's all kinds of strategies and research that people have done into ways to improve or get cooperation. History is just one of the things. There's randomness that you can use. Also, it's popular, and other techniques people have looked at as possible ways of achieving cooperation, global cooperation in the spatial prisoner's dilemma game.